The practice talk that we will hear is given by Minh Chau Nguyen and Klaus Kühnel from Wacker Chemie in Germany. Hi Minh Chau, hi Klaus.
Hello.
Hi.
It's great to have you here. So you're going to tell us more about your experiences of applying process mining at your company, and we're very curious what you've done. So yeah, please go ahead and tell us all about it.
Yeah, hello everybody. Thank you, Anna, for inviting us, and we are really delighted to be here and introduce Wacker Chemie and our use case with process mining. So I'm Minh Chau Nguyen. I'm digitalization manager at Wacker, and I have here with me my colleague Klaus Kühnel, who's from productivity management. And we're going to introduce you to two use cases that we have brought today. And our topic is productivity management. So we're going to explain what this is about, how we combine that with process mining, and how we really could save money with process mining. So yeah, let's start. Most probably, I guess you already had contact with our Wacker products. As I said, we are a chemical company, and we produce products actually for every major sector. So we are really part in your daily life. As you can see here, all the applications where our products are in. So we're really big in the automotive sector. So our silicones, for example, are in nearly every vehicle component to make them more durable, to make them water repellent. Or as well in the construction industry, we are really big with our binders and dispersions. And our slogan is to create tomorrow's solutions. So we are also here in the biotech industry for food supplements, for biopharmaceuticals. And last but not least, we are also in the renewable energy sector. And that's going to be the business division where we're going to have a closer look later today. So where did that start, this variety of products? Just a short look that where are we coming from? What is Wacker about? So the company history started with Dr. Alexander Wacker, who founded the company in 1914 in Germany, in southeastern Germany, in Burghausen. And here you see a little picture of that site back in history, just to get an impression how that looks like. And he had the visionary idea to use electricity for producing chemicals. And that's the start actually of Wacker. And this variety of products that you have seen in the beginning comes from these main 5 key raw materials that you see here on the left. So methanol, silicon metal, ethylene, acetic acid, and starch. Just to give you a rough understanding, those are the 5 key raw materials to produce this variety of products. And we're going to look deeper into the silicon industry, where we produce out of that semiconductors and also solar wafers for photovoltaics. So that's going to be the start of our journey. And coming now to process mining, how did that begin? So that's where it started in 2017, where I had the chance to write a feasibility study, to do a feasibility study about process mining. So actually my mentor, Dirk, brought that idea to look into an administrative process and to analyze that with process mining. And that's how I came to write a master thesis about that. And here on the right corner, you see when Anna and me first met in 2017 on the process mining camp. And I had my mind full of questions that I wanted to have answered for my use case. And on the next slide, you see then our Polysilicon Division. That's going to be then the start where Klaus Kühnel got a lot of work, because I was quite successful with my master's thesis. And that got you the job to do.
Thank you very much, Minh Chau. I'm proud to explain about my work from approximately 15 years. 15 years I'm in this division, and in between these 15 years, polysilicon growth up in a very, very fast way, and the result was really exciting. We have a cost ownership calculation that we never believed to reach it, and I'm proud to be the participant and be one part of the success story of polysilicon at Wacker. Polysilicon is one of the four great business units. They had on part approximately a quarter of the whole revenue of the whole company was earned in this division. And this division is a market leader. It's a merchandising leader, and from the whole company, they make a part of approximately 23% of the whole sales, market sales, and this is a very, very great successful. Approximately 10 times are growing up this market, and this is really a great challenge. It was a great challenge from the whole division. What you see on the map is where polysilicon is located. Currently, we produce approximately 80,000 tons per year. The mostly and the development site is here in Germany, in Burghausen. The air pictures show a little bit about the dimensions of such kind of production areas. A second one here in Germany, in the county of Saxony, near the town of Nünchritz, near the Elbe. We produce a quarter of our volume, and the youngest site is in United States, in the county of Tennessee, and this is also the same amount, although a quarter of the whole volume. Yes, this is what polysilicon is in general. To give you a little bit overview, where is our product, where are the resources of our product. The success story begins with the second available element of the earth, with silicon. The silicon can be earned by bauxitic manufacturing, harvesting process step, make metal silicon, interim production. And what we do is we make it into a high pure product, basic product, and this product is the resource, is the source of all the electronic devices and all the renewable solar devices what you have in your daily work, and which are growing up currently step by step faster than we like to do this.
So as we said in the beginning, the Wacker products are really part of our daily life. So nearly every second electronic device is most probably produced with our product here.
Yes, of course. It seems a little bit boring, our product, but it isn't. If you have the chemical and the physical understanding behind you, our product will, at our customers, improved to the electronic devices. The foils before you can see the shape and the different material sides of of our customers from the silicon rod situation. You can see it in the middle of this picture of this slide. In between slicing and grinding the surface and doping the surface, this is our which is done in our subsidiary Siltronic, and this is one of our success stories. We have the fast feedback loop between the production of pure silicon and the result of the final product, of the nearly final product. And though we can improve step by step our product, this is really a great benefit.
Yeah, and we're just going to look a little bit also into the value chain just to make you clear what we are talking about, and that's going to be the basis of our use case later. So here you see the history, how it evolved, right, Klaus?
Yeah. Yes, of course. You see on the top of this slide the basics, the foundation of polysilicon is on the electronic side. Our Siltronic, our daughter, 100% daughter of Wacker, produce in both possibilities to improve the polysilicon, the polycrystal, to a monocrystal wafer using by Tucholsky process or the floating zone process. You can see it on the second picture on the top. And then after slicing, this is the output of our daughter of Siltronic, and the customer of them, they produce electronic devices. In the end, our mobile devices, our computers and so on. But it's only current from the point of now, it's only 10% of our production line. 19% are the solar system, our renewable-based production. It's the same, nearly the same product steps are done. There are a kind of slicing, yes, of course, the wafering. You come from the ingot to the wafer, and from the wafers to the solar cell, and the solar cell to the strings, to the modules, what you can see on a lot of roofs currently, and that will be improved more and more on great fields. You see it near the trains, near the highways and so on.
So yeah, now you got a little bit of the context of one of our products at Wacker that we are producing. And we also promised you to give you an explanation what productivity management is about. So I think maybe not all of you are familiar with that. So as you can maybe guess, it's really related to the production efficiency. And Klaus, you're the expert, so tell us what we do in productivity management.
Yes, of course. It's a very interesting point of creation. Productivity management in the term of Wacker means we are part of the generation of new fabs. This is a factory planning basic approach with methods, an agile manufacturing style, and our education system is based on the Six Sigma education program. It's called Wacker Operating System, and from this we use all these standards like Lean, like Six Sigma, like process simulation. This is our S-curve, we call it S-curve. In between, we use several tools, and in addition to our Lean and Six Sigma basic tools, we used process mining. And process mining, we use it especially at Wacker approximately 2 years since 2019, and we are very successful. We got a new view of our problems with this transparency making product.
So, and that's actually already a good hint to our first example, which is about the poly deposition steps. So now we got a little bit, a feeling what comes out. So those are the chips or the solar wafers, but we need to understand now what's the production step. So could you give us a little introduction to that?
Yeah. No. In between, from the silicon metal side, we use the gas phase that is both the first two blocks you can see. The basic chemical side of our site, it's called silane production area. It's really a chemical-based production area. And then on the third and the fourth block, you see batch devices. Batch devices, that means we have lots, we have bounded to lots, and this lots begins in this deposition reactor unit. This reactor unit transfer from the gas phase to the solid phase, and from the solid phase you can see it on the right side. There are the aimed harvested rods, and these rods will crushed to we call it chucks, and these chucks have different sizes, and these sizes are the basic for example, for Siltronic or each other monocrystal or polycrystal developer and manufacturer for electronic and solar industry.
So it's a very highly sophisticated production process with high temperatures, a lot of knowledge required, and a good timing. So now, the question is, how do you combine it now with process mining? How did you start then with your project?
Yes, thank you for the transfer to the really daily life. And the really daily life, I thought it's based on our Six Sigma tool, and it's very helpful to use 5 phases of the DIMEC, the define phase till to the control phase. You can see it on the top of this slide. And what this slide means, be careful in the first definition phase. That means you need the exactly questionnaire before you start the project. What is the question? Mostly the costs, but the costs is an interim or the end, and we need the physical one. For example, the output is our currently most efficient key performance indicator, and this key performance indicator we want to improve. But be careful. The difficult is have the understanding of the process. That means on the left side you see makes the right questions or creates the right questions. On the right side you need an expert. You need the situation on the database. This is necessary to get the right and the possible way, and this is in the define phase very important, and you have to be very, very careful in this time space. Spend a little bit more time, and then you will be more successful in the other phases.
That means, firstly, you defined the scope with the correct questions, and this question was about your key performance indicator, which is about more output, more capacity, and that could be maybe aligned with if you need less time for that, right?
Yeah, exactly. And especially in this project, the next phase after you have collected the data, you go in a first loop, in a first rough loop, collect the data, make a first view. Pivoting is the first selected thing for data expand, data compressing. We use Minitab, for example, for compress the data, and got an overview what is going on and where are the non-value adding times, for example, or where are the quality problems. This is the current approach to achieve our targets. Yeah.
So you look for the data, with your experts which data sources you have to look at it, so that you don't get confused. You ask the right questions, and then you combine the different data sources, you get this pivot table, this huge pivot table.
Yeah, it sounds very simple, but in the daily work, it isn't very simple. Not the data collections, SQL, and this technical side. It's good, and a lot of experts are available, but interpretation needs to know what is really going on, what is the meaning behind the data, and pivoting or compressing with any kind of analytic tools is one step, but the transparency isn't always given.
So that's when process mining plays a role now.
Yeah, exactly. Here is a great benefit. And my first approach was, it's not necessary. We have our currently work, but especially in this startup project, we see this is really necessary. And the process map means you have the data compressed for Disco, especially for some different parameters, especially the time scale, the starting time, the end time of standardized status. And this 3 rows with an initial indicator counter is normally the basic, and this is not enough. You need different possibilities to adjust the data, to select the data, to filter the data, and though you need additional parameters, additional rows in Excel, for example. Normally we use Excel. Here in this process step, you can see process mining, especially Disco, is able to enlarge, to compress all the views. In the end of the process, you get a really better overview. This picture, or this slide, what we currently see is, yes, the data are founded and fixed. The second loop is a loop between the analyze and improvement. Process mining give us the transparency, what we had not given in the past, and in combination with our other standard tools. Here you see a slide from Tableau. It's a visualization tool what we used as a dashboard thing, and the combination and the loop. This is the basic of answers the questions and give the potentials which are in the system.
When I looked into my feasibility study deeper into the data, I couldn't do that all by myself. I needed the process experts who could give a bit more details what is going on there. So in your case, did you do that all by yourself?
No. It's not possible. It's only a kind of leader. And what we need are experts from different departments, devices, responsibilities. And although it's not really necessary to have a deep process understanding, but in combination, the experts and the view from the other side, it's really a side view necessary to look on the data, to look on the transparency data from process mining especially. And with the method, for example, we like to use the methods like the design thinking. We play what could be. We make expectations. We make the results. We play the results and look for we can reach the results in the group. And the group is very important. Not too huge, not too many, but a very interested and involved group, which should be on the project the whole time. And it's really a short time space what we currently use for this. this gives us additional views and the possibility to reach potentials.
So we know now in theory, okay, how do we start? In productivity management, we start with the project defining, measuring, analyzing. So we go the DMIC cycle. We know in theory, okay, you looked for the data sources, you had the right questions. It's a lot of teamwork, which is maybe sometimes frustrating, but sometimes gives a great benefit. And in our case, what was the task then? Let's go into the use case.
It's a use case. You have to switch on the problem itself, and after we stay in the process analyze phase, and we have a discussion. Especially here, we have defined our task. We have the situation here, especially 16 main process steps, and we have collected the data for 2 years, and we had the step analysis of the 16 process steps. This is necessary to get the basic for the whole project.
So, and as we remember from the beginning, we have those 3 production sites, the main production site in Burghausen, in Nünchritz, and then one in the US. There you took, from this specific production step, poly deposition, you took the data from the 2 years, then you compared them.
Yes, of course. If I explained, it's necessary to have additional parameters, attributes to the data size, and one of the attributes was compare the reactor type. It should be the same. You have to homogenize all this technical things, and then you can select, for example, here. Normally, your expectation is this approximately 550 starts go the directly, strictly way what we defined. Here in the regular process sequence, it was, and this was our expectation. But in the reality, in the comparison of these 3 sites, we have deviations, and these deviations give us the hint where is different. Especially here in a site, we have only 30%, 33% in a regular way, and the other 67% goes an irregular way. How comes, and what is really behind? And this is a kind of fork process situation. But if you go deeper, the second and the third level, you see, this is mostly a lot of things are not in a regular way done. It's shortened, and this shortened has a reason. And in comparison of these 2 sites, we see it's a different behavior. It's a different process, and we go with the technology colleagues in discussion, and the result was, yes, of course, here we have differences, and what are the reason? The site, so the best site with the irregular steps goes to an irregular way. That means they wait until electrical disturbances occurs, and after this occurrence, we have the possibility to go by a faster step in the cooling phase, and this cooling phase was shorter, and the shorter, that means they have 2 benefits: the greater diameter and the shorter cooling. That means all in one, more starts per time period, and this was a difference. And then we go in discussion with our development colleagues, and the result was an improved process, and this improvement was our game?
So you compared the two sides with the data based on 2 years. Actually, you thought, okay, the 16 steps should be done by every side. And this transparency that we got now with process mining was then, okay, the real process is different. Although we thought the two sides do the same, the Nunscript side is doing an irregular way, which is then actually better because it's shorter in time. And then, okay, you're looking for your KPI, to get more output, to increase the capacity. So if you have a shorter production time, you could save money with that.
Exactly. But it seems very easy, but normal analysis of the process, it makes it very difficult, and you need a lot of process understanding. But with this kind of transparency, and the slide shows us the slope, for example, is for me always a really good parallel system. The slope is seen, and you see what is going on, what was the wrong behaviors, the wrong motion of the skier. That means what is the difference between our processes and the process steps.
So you saved 17 million euros per year with this transparency.
Sorry.
That's quite amazing. That's really a great success.
It's it's a really small basic effect, and it has a great amount, especially here in the bottleneck equipment. This bottleneck equipment we can calculate with the full cost of ownership calculation, and this is the benefit, a great benefit, and this is the basic for our ranking, where additional potentials available.
So with the right method, you got also then the chance to discover process mining in another application. So tell us about then our second example. What is that about?
Yes, of course. It's very interesting. The second example was based on the human optimization. Nearly the same questionnaire. The task was the same. We improve our quality. Improvement of the quality. That means our dynamic samplings. Our samples have to improve, and we have no. We have this task, we have this order. With the same equipment, we have to reach a great amount of samples. And this was in the analytics, in the physical analytics of polysilicon. We had approximately 55 operators, analytic operators. We have, they work approximately 250 samples per day on nearly 100 measurement equipments in a 5-shift work flow. And this was the basic, and what we can do, in which way we look for the data. Yes, of course, we have we make it in the same 3-step loop, collect the data. Collect the data means in this project not only related database data platform is enough. We need also the human database, and the database is not always so simple available. You need different sources and different understandings what is going on during the whole day, and this is what on the first step, collect and compress the data, you have in your mind. You have to be in your mind. The second one was analyze. We talked about the analyze phase in between, and this is the position of our process mining tool. In addition, with other tools we currently use to get an overview, our workstream analysis is a basic tool of the production management side, and our work step analysis. This both normally are enough to get an overview what is going on in this area. It's a static scratch of the dynamic things, and the static is not information enough. But in addition, with the data compressing, especially with process mining, give us a possibility to bring it to new dimensions. For example, for time, for low locations, on which locations, in which manufacturing areas, and which quality of product, of measurement equipment and operators can we adjust all the data and optimize to value-adding times.
So let's dig a bit deeper into those 3 steps to get a good understanding. What did we do here? So in the first step, you said, okay, value stream analysis is really crucial to get a good understanding.
Yes, it's my preferred first approach to the project. On the slide, you can see on the basic the physical things. That means which kind of carriers we use, which kind of operational scenarios what we have in this area. That the color shows a little bit the responsibility of the workers, and the core systems, orange cubes shows the process steps in between the storages and the different capacity of each of the processes, and the storages give us an impression what is going on. And on the top of the slide before, you can see the information way. And this is necessary to get this 3-step, to begin with the 3-step. The first thing, as we explained, the database selection with the questionnaire, with the possibility to reach the data. This is the first step. The second step is our compress and analyze the data. This data, I explained it, are based on 2 different kind of data. So exactly database related data and the data, handwriting data from the workstream analysis. This both in combination give you the basic for the analyze phase, and in addition you have to analyze the data. And what you can see here, it's not really a good picture, but it shows how complex and how the support and activities here in this physical analytic area are. And all those
colleagues were shocked as
they
saw that, right?
Yes. It's not so easy to understand, especially the supervisors and the responsible colleagues are really shocked, and it was an amazing picture. But in the end of all these things, you have to select the data, you have to compress it, and here you can see it. This mountain picture is the workload during the whole day from midnight to midnight in these 5 different groups, working areas, and you see on the back side there is a very high workload in 2 different areas, especially during some morning time, and this peaks combinate or compressed in the valleys of the workload, especially in the evening, in the late shift. We can do some probes, activities, and this was our goal, what we had reached, and this goal has has a great benefit to improve the capacity, and in addition, we have the possibility to shift 5 workers, 1 worker per shift, to other very interesting and important working areas. In some, it's not 70 million euros save. It's only 5,000 euros per year, but it was the first approach. We go in this area step by step, and in the second or third loop, we are sure we can improve without any automation.
So that's really interesting to see. Okay, process mining is really tangible. You can really create value contribution with this transparency. And that's why there are lots of other projects already in progress or planned. So here you see just a rough overview what's in the backlog. So that's going to be a continuation of the journey. And I'm very happy that we have the chance to do that at Wacker. And we see, that's how process mining complements our productivity management tools with Lean, with Six Sigma, and it really is a great value-adding contribution in our cycles to reduce inefficiencies, to increase the labor productivity, but also really in the production process, as you could see in the first example, we could really save time in our operations. So great examples that you brought today, Klaus, and I'm really happy that we could share them now with the community here. And what could we summarize about process mining? It's really interesting. It gives another perspective, gives also a profitable addition to our current tools, but it does not replace the task definition as we saw. So you need to have an understanding of the underlying process. You need the process experts, and you need to know where the databases are. So that's a basic homework that you have to do.
Yes. As I explained, be careful on this thing. This is a key phase in the whole project to adjust and have the right data. The data preparation needs really to understand and has to be in account to all the further steps. This is what we see, the visualization. And the visualization, I can only highlight it. The visualization gives us really a great approach and understanding, especially on the management explanation. If we need some additional resources, we show this kind of transparency. I'm sure we got every resource what we need, and this is very helpful. But here it stays. It not replaced the experiences. Be careful. It's not a wonder tool. It's necessary to understand the process. Be careful. Be exactly. Make the workstream analysis. Go with experts in discussion, and in the end, you will reach a very successful project, not independent from the amount. It's interesting to get all the things. But the last point, this point, the social competence, especially in the second explanation, what I have done in the physical area, be careful. There you deal with humans, and the humans has to be, it's really necessary, bind it or bound it in the first phases with the questions, with what is going on, bring it in the group, and this is really necessary and help to understand and be not worry. It's not a man-saving tool. It's more an optimization for the workflow. And this is what you have to deal with the human part.
We hope that you got a really good understanding of our Wacker world and about process mining and its effects. And thank you for your attention.
Thank you, Minh Chau. Thank you for listening.
Thank you both so much for this very vivid presentation. You really took us also through the process, the production process that's behind it, which of course, if you're not working at this company, it would be hard to imagine, but you really managed, I think, to take us into this world, and then to really show how process mining can contribute to process improvement work in this area. So really nice to see, and thanks a lot for sharing your experience here at camp. So we have a little time for questions. Please add anything you want to ask Minh Chau and Klaus in the camp community on Slack, and I'll get started with a quick question for Minh Chau first. So when you started with process mining during your project, was it immediately clear to you, like, who owns process improvement? Was also a question we got on Monday after the discussions that we had there in kind of the process improvement discussion in a different sector. But who is responsible for this? Are people doing this all the time? Are there more project-based kind of improvement projects? How did you find out, and how is this organized in your organization?
So luckily, I knew who is responsible for the process improvement. So that's actually really the task of productivity management, and that's where I started the master thesis. So that was quite clear who's responsible, which was maybe not that easy as if you look at a really broad process or a broad process improvement step. You get in contact with other department who own the data, and that's something where you have to be really crucial if you start your process mining or your first process mining project, that you keep the scope not too big. So here we saw with the example from Klaus, it was really a condensed question, a really condensed scope, and that helps you then in the beginning.
Yes, that's a good tip to keep in mind. Thank you. Okay, a second quick question for Klaus. You have shown this slide where basically the S-curve, you called it, of the productivity management was shown, right? Where there was also this one, this kind of vertical line where it went from system N to system N+1. So it's kind of a new generation at the end of what you could improve from the old system. So that's how I understood it. And my question is, like, you as an experienced productivity manager, so how do you know that there's still room for improvement? Maybe at some point in time you hit a plateau, it seems like there can't be anything more, but how do you know that you still can have more ambition to try something else?
Yes, it's a typical, and you need really a lot of experiences to switch, for example, from one S-curve to another S-curve. It's a feeling. Is it really necessary to improve it? You got all the things. So y-axis is what is going on, what is the improvement, in which time scale, when you see the x-axis as the time of a product, of a process circle. On one point, if the curve is go to the horizontal line, it's a feeling, you can measure it, and this is normally goes hand in hand with technology. Currently, we are in the digitalization. We have installed Wacker Digital Group, a really great organization, and they give us daily new tools, new possibilities from the classes, all possibilities what is possible, and this is an indicator you can change the S-curve to a new technology, but be careful. not only the new careful is the best solution for improve the process. You have to, at first, you have to see this improvement does not give additional potentials, and in this case, you have all things done what can be do without any additional investment. The investment, and in the end of the day, that's the fourth generation of industrialization is the question. It should be adapted. It should be included in the human of each of the factory. Not high end is the question. It should be adapted to what is possible and what should we do and what we have in the prioritization list.
Yes, very clear. Thank you. Okay, great. Two quick questions from the community, and then I think we go into a quick break. So, Sudansu was asking, is the quality of the final products dependent upon the time spent by materials during the work in progress stage in your case?
The question, I'm not really sure to understand the questionnaire in the right way. All our activities, I try to explain it. It's a cubicle between quality, security, so this productivity, and the diameter, or in the end, the price. And we hope all this questionnaire is based on optimization, yes, of course, from the price, but also in all other dimensions. I hope I had the question understood in the right way.
Yes, I think so, yes. And maybe one last, a little bit kind of process mining question. So in process mining, of course, one of the dimensions is the case ID, right? So the case ID determines the scope of the process. And then, all the events are correlated to one instance, so one case ID. So one problem that in manufacturing is quite common is that you move in the course of the production process from multiple pieces that are then actually put together, maybe in one batch, and then afterwards, so basically the case ID changes throughout the course of the process. For example, if you have 4 wheels of a car and you put them together into one car, then after this assembly step, you have like one car rather than 4 wheels, right? So this can make some problems when you're trying to analyze the end-to-end process when the case ID shifts throughout this process. I'm curious, did you have any challenges with what the case ID is with the types of projects that you have done so far, or maybe not?
It's not really an assembling. It's difficult to combine it. For example, for the car manufacturing industry, we are a batch industry. We have not an assembling part. We improve our process step by step, and what we have to reach is the maximum of value adding of our product. Clear, we have byproducts in the same way, but it's not an assembling. It's more an diversion product in forward with some small rework loops. This is a difference from the assembling side. Yeah. But our approach and our challenge is to bring non-value adding times out of our line. This is our basic thing. Have the few of our silicon piece go through the line, and the colleagues, the other pieces, bind together to a batch, to a lot, and this took any improvements enlarge or combine process steps to have really in a kind of one-piece flow possibility to improve the process.
Yes. Yeah, I see. Okay, very good. Well, thanks again, both of you, for this really interesting presentation. And we will go into a brief break now. You can still ask questions, and we will all be in the camp community, and we can continue the discussion there. But we will also be back. here just a quarter past the hour, together with Joris Kaisers from Weco, and Klaus and Minh Chau will also be there, and we will talk some more about process improvement in the production industry. So see you in just a few moments.